Hi guys. All right, now you're welcome to my channel. This is a continuation of our previous exercise where we discuss about wiring installation of buildings and electrical craft principles. I always advise us to come from a solid and controlled background whenever we are going to automation space. So this is not a kind of deviating from automation channel and going into installation of buildings. No, it is because I want you to work with me. I want us to be on the same page. I want you to understand every bit of my class. Okay, so due to the questions and the requests coming to me concerning electrical connectivities and the craft principle related issues, so I have to take us back to electrical craft and principle and conventional and basic electrical concept before we now come back to our control and automation. Okay, so today class, even including the previous class, is all about two-way control and electrical craft principle. Okay, so we are still going to do this two-way control, but I want to bring you to the subject of the issue. The subject is that why do we need a two-way control? Two-way control we use, for example, look at this pictorial view. This is a staircase, and this is also a staircase, and this is a dual staircase going to different location. You will ascend from here, you will descend from here. Okay, this is a very big educational institution. Okay, so this complex now has multiple exit and multiple entrance. All right, so because of that, we need to install what we call two-way control system so that wherever you are coming from, you can activate the lighting system. Whenever you are going from, you can also deactivate the lighting system from there. All right. The same concept will adapt when we want to do bed switch. Okay. You go to your bed while reading your books on your bed and maybe you sleep off. You can wake up and shut down your lighting system from your bed instead of coming out to go and switch off the lamp. And if you wake up want to come out, you can also put on your lamp from your bed. Okay, so that is the essence of doing this. And it's not just that, the ability for you to understand the function of that two-way, you will apply that particular idea to so many connectivities you want to go through. Okay, so that is it. So now, like for instance, if you go to institutions where they have about four different corridors, long corridors, and they have more than two, three staircase. So you make sure you synchronize your switching control. Synchronize your switching control such that wherever you are coming from and wherever you are exiting from, you should be able to control that same lighting system. All of them will be coming up the same time and going off the same time. It can be more than 1,000, more than 50 lighting points. It can be more than 50 lighting points controlled by that same system, depending on how you segregate your load and the strength of your switching system. Okay, that the integrity, that the switch rating of your switch, what I mean. Okay, so now let's, like I said, I don't have simulation function in my AutoCAD. So this AutoCAD design, so what I will do for us to practicalize the connection method, we are going to open our control system software and do the practical there. But the subject remain that if you want to control lighting system from various entrance or various exit, you must synchronize that connection such that whoever that is going out from any of the point, any of the entrance, any of the exit should be able to access illumination system by putting on switch close to that particular position. Okay. Then whenever I want to put off the lighting system, anybody going out from any of the position entrance exit should also be able to access any switching system to switch off the lighting illumination. Okay. So now let's go to control system and let me see if I still have one example. I think I should have example here, something like this. Okay, this is a practical example I showed us before. So this is a staircase. Okay, this is just the simple beginning of how you understand this. This is my staircase. If I want to ascend here, if I want to ascend from here going upstairs, I will put on this particular switch, and this switch is one-way switch. Sorry, two-way switch. Okay, two-way. The name is one gang two-way. That is the name of this switch. One gang two-way switch. So because it's two-way, the meaning of two-way is that I can activate from here. I can also activate at the second place. That is why it's two-way. One way is this. The second way is this. I can on from here, I can off from here. So that is why it's bearing one way, one gang two-way. The name two-way originated from owning the point from 2 point. The name one gang originated from the switch in question has only one button. Because it has one button, that is one gang. Because it's two-way control, that is the meaning of two-way. Okay. All right. We also have two gang two-way switch, meaning that these two button, but you can use it for two places. We also have three gang and two-way switch. It is three gang and buttons, but it's also two ways. You can use it to control another three gang elsewhere. All right. That is how the name implies. So the function of this, there is also another one called intermediate switch. Okay, one gang two-way has three buttons. Sorry, has three terminals. One of the terminals name is common. The other terminal is line 1. Another third terminal is line 2. That is for one gang two-way. Then for intermediate switch, we have line 1, line 2, line 3, line 4. Or we have line 1, line 1, line 2, line 2. Whichever one, how you want to understand it. So it has four buttons, sorry, four terminals. The particular one gang intermediate switch has one button, that is one gang. But the terminals, the total terminal includes is four terminals. Remember, this one is three terminals, common, line 1, line 2. This one has two input and two output, two incoming and two outgoing. Line 1 is coming, line 2 is by the side, then line 2 is going out, and line 2 is also going out. Okay, input is 2 and outgoing is also 2. All right. Okay, so that is why it has a four terminals. So let's go to where we are going to use a control software to simulate how you can operate that particular circuit and how we can design the circuit. Let's go. Um, okay, this is our control. So let's see if we can design the circuit by using my control switch. This is a control switch. So we are going to use this control switch to illustrate. This is typically how it looks like. Looks this way. Looks this way. Looks this way. Okay. Then you have something like this. This is the common. Okay. This is the common. This is line 1. This is line 2. This is common. Okay. That is how the switch looks like. There is internal structure. Internal composition is this way. This is common. This is line 1 and this is line 2. Okay. Let's see if we can just hold on. This is common terminal. I want to make sure you understand the concept before we now design the circuit, okay? Then this one is going to be line 1. Then this one is going to be line 2. Okay, this is common terminal. It is common because it is common to these two. This one is connected to this. Then this one will be connected to this as you activate this. Okay, this one is common. At every given time, the common must be connected to either line 1 or line 2. It cannot be an intermediate. It cannot be in between. It must be either it's connected to this or it's connected to this. Okay. All right. So now this is the structure, physical structure, internal composition of this particular switch looks this way. One terminal here, one here, one here. That is it. Now I now want to use this control. Let me say this one is going to be S1. Okay, this switch one. So I want to use this one to represent that same configuration because this is two terminals. Terminal 14, terminal 12, and terminal 11. 11 is my common. Common is now connected to 12. So in a control language, we call it NCNO, normally close, normally open. This one is common, closing to 12. So this 12 now is normally closed. Then 14 is normally open. Normally is because on idle mode, when the switch is not activated, the the state of the switch that time is the name we use to represent the contact. Now because the switch is not activated, 11 is close to 12. 11 is connected to 12. So in that case, 12 is connected to 11. So 12 is normally closing with 11. Then normally too, 11 and the 14 is open. They are not closed. So that is why 14 now is normally open. 12 now is normally closed. So that is the name. Okay. Now I want to use this to illustrate the operation of two-way control system. Okay, in a building. All right. So because of that, for more simplicity, we are going to rotate this. Hmm? Pardon me, let's rotate it this way. This is 14 terminal and 12 terminal and 11 terminal. Now let me get another one. Let me get another one. Uh, we need two. Okay. Now let me turn it this other way. I want it to face me this way. Okay. All right. If I have it this way. Now just listen. Pay attention, please. The law of two-way control system stipulate that one of the switch of the one gang two-way should accept the supply, incoming supply. The incoming supply live cable should this one should accept one. This one should be connected to one. Then feeding the lamp that we want to electrify should be going out from the second one of the switch. I repeat again, the law of this connection stipulates that the switch one, it should make one and make one two. Let me take this one as switch one. Now, switch one now should take the incoming supply of my live conductor. Then switch two should take my outgoing of that live conductor going to lamp. Let's practicalize it now. Now, I want to feed, let me space it because there's one other one we want to introduce called intermediate. Okay. When we are done with this, we bring in intermediate. So I want to light up, put up a lighting system. Let me make it 1, 2, 3, 4. I want to light up this 4 load. This is my lamp now. I want to use this two-way to control them. Supposing I have two entrants to be coming into this particular facility to put on this. So what I will do, this is my, let's feed my supply. According to the law, this is my supply. Then this one is going to be my neutral. Okay, live and neutral. Now, how do we go? Just listen. The law said the switch one should accept supply should be terminated to one of the switch of one gang two-way. I have two one gang two-way, one here, two here. This first one should accept the incoming. Then feeding the lamp should move out from the second switch. So let's do that now. Let me feed the lamp. Sorry. Sorry, this my mouse is disturbing me. Oh God, man. Okay, don't worry. Let me just see. Okay. Um, just hold on. Okay, this one now come from this way and supply the lamp. I have 4 lamp to feed. Even if I have this lamp 50 pieces, 50 point, that is the way I will electrify them all. Okay. Now the law, like let me repeat again. Switch 1 should terminate, the supply should be terminated to the first switch. And that first switch should be on the common terminal. The common terminal of switch 1 should accept the incoming supply. Now the common terminal of the other second switch should take the outgoing to the lamp. So the two commons are done. The connection for the two commons are done now. So I want us to now do the second instruction. The second instruction said these two travelers should be interlinked. These two should be interlinked. Line 1 and line 1 should be linked together. Line 2 and line 2 should be linked together. Okay? Line 1 to line 1 should be linked together. Line 2 to line 2 should be linked together. Though quite unfortunate, this arrangement now does not permit my terminal of the 12. Okay, let me change them. Let me change them. I want this one to be 14. I want this one to be 14 here. Then this one should be 12. Okay, I want that uniform. Okay, 12 terminate to 12, 14 terminate to 14. But in a reality, for wiring for that particular circuit, that particular socket, the number is going to be line 1 and this one should be line 2. But because we are using control software, we don't have such connection. We don't have such switch, switch. The particular switch we have here is this particular one we have that is similar to that particular function. We don't have such line 1, line 2 switches. That is as accessories for buildings, building switches. We don't have them here. So that is why I now use this one to make but the same function, the same close and open. Okay. So now interlink these two. Let's define their names. This is common terminal. This is also common terminal, and they have performed their job. Now, this other one, they are travelers. The names of this one are traveler or striper. Either stripers or traveler. That is the names of these two that link each other here now. Now, what is the left in our connection is to send the neutral to the lamp. Let's send our neutral. Sorry, this software has a concept to follow. If you miss your concept, you okay. This is our neutral to the lamps. Right. So now this is switch 1. Let's define this one to be switch 2. Okay. Now this one can be which color? Perhaps green. Let's use red, yellow. Let's say blue. Maybe green. Okay. Let's simulate and see. All right. It's on now. If I want to shut down, I shut down from here. If this one shut down, this one can put it on. I can on from here, off from here. I can also on from here, off from here. So any other place, if I come in from here, I put it on. If I'm going out from this other direction, I put it off. Okay. Now that is how it operates. All right. Now, how does it function? I want you to take a look. Trace your, like I said, always maintain your continuity. Check your continuity. Let's check our continuity. With this position that is on now, this is my supply coming here, closing to 12. Continue. come here, closing to 11. So it's continuity. The continuity is complete. It come to the lamp. If I want to shut it down, I shut down. Then trace your continuity. From here, supply, come here, go through. Come here is open. It's open. This one has closed to the other side. So that is why it's off. Okay, that is continuity. Now, that is the way you do your two-way control. Now, supposing I want to control from three direction, what I will do is to employ the services of what we call intermediate switch. So let's bring intermediate in now. Like I told you about intermediate has 4 buttons. Okay, that is S3. It has 4 buttons. Remember that two-way has 2 buttons. This one is 4 buttons. So what we are going to do is to take away this and take away this and insert intermediate here. Then interlink your connection again through intermediate. Link this to this, link this to this, link this to this, then link this to this. Simple. That is the work of intermediate. Intermediate simply means if I have 1 here and I have 2 here, between 1 and 2, what is at the center? Something must be intermediary 1 and 2. So that is why the name is intermediate. You want to intermediate between this 1 and 2. You want to be in between them. That is the name intermediate. Something has to be in between 2 things. So when you are in between 2 things, you are intermediating, you are an intermediary object. So the job is sounding like the function. So that is why it's intermediate. Intermediate is that before you place this switch, it must be in between this uh, one way two gang and this other one way two gang, one way two gang, one gang two way, one gang two way. You cannot put it here, it cannot work. You cannot put it here either, it will not work. It must be intermediate, it must be in between one gang two way and another one gang two way. It must be in between them. That is the name intermediate. So it must be an object intermediary between 2 points. So in this case, I can control this load through 3 points, 3 exit point or entrance. Supposing I have something like this. Supposing I have, let me say I have one entrance here. I have another entrance here. I have another entrance here. Wherever you are coming from, you have a switch close to you that can operate this. Whenever you are going out from any of them, you can also shut down from there. So let's simulate and see. It is on now because one of them was off before. So let's trace which one was on or off. Look at this one. This one was on because look at my supply. Here is closed. Here is open. So this one is off. Here is open. And this one is closed. So when it's closing from here. It passes through here and bypass. You're now connecting 1 and 4 and pass through here. Now the work of intermediate is to close, like I have this one passing by intermediate. Now work of intermediate is closing 2 and 3 and also closing 1 and 4. So let me off this light from intermediate. Look at it, I shut it down now. So 1 and 3 is closed, 2 and 4 is closed. That is closed circuit. Then if I want to use that to activate that lamp, I will now activate it. Then 1 is going to be connected to 4, 3 is going to be connected to 2. It's going to now diagonally connect each other. Look at it. Look at how this one functions. It will connect by diagonal position. Look at them diagonally. That is how this one functions. From composition of this switch, once you operate it, it's going to connect diagonally, internally. Okay? So that is the job of this. So I can on from here, off from here. I can also on from here, off from here. The same thing applies here, on from here, off from here. You get? I can also on from here, I will off from here. I can also on from here, I will shut down from here. So that is the method of using two-way control. Now, supposing I want multiple exit, what do I do? Is by piling up your intermediate switch. I repeat, The first stage is for you to understand these two, for you to use this one to control from two different exit or two different entrance. Now, if you need three exit and above, I repeat, if you need more than two, you need three and above, all you need to do is to keep inserting this in between them. Let me get a sample again. If you need four position, now, like now I have three position. If you need four position or how many positions, see what you do. Let me repeat again, pay attention please. If you need to control lamp or lighting system or lighting illumination from two positions, you use this one gang two-way, two of them to control. One for one entrance, one for exit. If you want to control that same load from three positions, you employ the services of an intermediate. And intermediate, you insert intermediate between the two, anywhere within the two. Okay? Anywhere must be the third entrance. It must not be just anywhere. It must be third entrance you want to control from. So this is entrance one, entrance two. Entrance three is where this one will be. Then if you have another entrance four, you now insert this one. If you need another entrance five, you put this other one here. It can be anywhere. If you need another entrance, keep multiplying these ones. Keep putting them on that entrance. Just keeping them and link them up. That is just all. Okay? All right. So any other confusion, contribution, put it on the comment section. All right? All right. Thank you. Let's simulate once more. I on from here. I off from here. I on from here. I off from here. So that is how you use your two-way control. Okay? That is how you use your two-way control. All right. Thank you.